In this lecture, we're going to start a new chapter. This is chapter 12 on shear strength of soil. And this is a very important topic in geotechnical engineering. If you take a look at the list of our course objectives here, so this chapter actually relates to two of the main course objectives. The first one is to determine the shear strength and shear strength parameters of soils from field and lab tests. And the second one is to determine the normal and shear stresses at a point in the soil mass and use the Moore-Coulomb failure criterion to evaluate possible failure. So two of the main course objectives relate to this chapter. And before I introduce this concept of shear strength, so I want to show an example a case that relates to this concept. So this is the Osa landslide that happened back in 2014 in Washington State. This is a picture of, let's say, the slope after the landslide happened. And this is really a catastrophic event. So we know it caused casualties and economic loss. So right before this landslide happened, actually there was a huge amount of rainfall during a period from February to March 22nd. And this precipitation was recorded by a number of weather stations around this landslide location. On this picture, the cross at the center here, that's the location of the landslide. And there are a number of weather stations that provided precipitation data. And if you look at this summary table here, so that's precipitation data, and it's focused on just the last row here. So from February 1st to March 22nd. So March 22nd is when the landslide happened. The precipitation records, actually, the data shows the rainfall during this time period is over 200% over of the normal long-term average during the same time period. And actually, rainfall triggered landslides are the most common type anywhere in the world. And there are a couple of reasons why you see landslides happening after heavy rainfalls. The first one is because of the rainfalls, the initial surface soil, the moist surface soil will become saturated. And this saturation of surface soil actually leads to increase in pore pressure. So you have increase in pore pressure. And we discussed this back in chapter 9, effective stress. When you have an increased pore pressure, the effective stress in the soil actually decreases. So the effective stress is what's holding soil particles together. So that provides the resistance you need, or the soil needs to basically resist any external stress. So this is the first thing that heavy rainfall does to a soil. And the second is for this sloped ground where landslides happen, the rainwater actually creates a seepage. So the seepage becomes the driving force that pushes soil blocks down. So with heavy rainfall, you have an increase of driving forces. So a combination of these two factors, a decrease in resistance and an increase in driving force, cause the slope to fail. So in this chapter, we're going to talk about the resistance of soils. So we quantify or we measure the resistance of soils in terms of its shear strength. So strength in general means the stress at the state of failure. So basically the maximum or the ultimate stress a material can sustain. So that's the definition of strength. And in geotechnical engineering, we are more concerned with the shear strength and the shear stress, because most of the time for most geotechnical engineering problems, soils tend to fail due to excessive amount of applied shear stresses. Soil is pretty good in terms of sustaining compressive force, but if you have an excessive amount of shear stress, and that's where you start to have problems. So in the soil, when the stress in the soil is greater than its shear strength, we say the soil fails. So there are two related concepts here that we're going to discuss next. The first one is this stress concept. So to determine if soil fails, you need to know the current stress in the soil. So you need to know how to figure out what's the stress in the soil along any planes. And the second concept is this strength or this failure concept here. So to determine the shear strength, you need to define what is failure. So these two concepts are actually what we're going to cover in part 1 of this chapter. So Moore's circle of stress. So the first one, so this is a method we're going to use to determine the stress in the soil mass at any point in the soil mass along any direction. And this is actually chapter 10 in your textbook. So I bring this concept here because it's more relevant to what we're going to talk about. And the second one is that failure I mentioned. So the most commonly used failure criterion is Moore-Coulomb failure criteria. So we're going to discuss that next after Moore circle stress. Then part 2 and part 3 of this chapter both deal with how do you determine the strength parameters. So this includes some laboratory tests like direct shear tests and a number of triaxial tests that we're going to cover. Then there's also vane shear tests and some empirical correlations. And sensitivity clays is something we're going to briefly touch on at the end of this chapter. So that's the plan. For today, we're going to focus on this very first item, the Moore circle of stress. And so if you took structural mechanics before, you will find this is basically a review of some of the concepts.